Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on October 28, 2025, about 2 days ago. It introduces a reflective autoformalization loop with a new training method called Prospective bounded sequence optimization, delivering an average improvement of 17% over the strongest baselines, and it adds consistency check with 859 expert items to test reliability. The paper is titled ReForm, Reflective Autoformalization with Prospective Bounded Sequence Optimization. And as we'll see later, the implications for model training are quite significant. Also, the authors shared a GitHub repo. You'll find inference scripts to run ReForm, pointers to the released 8B and 32B models, and pre-processed test sets for Mini-F2F, ProofNet, Putnam, and AIME. The README walks you through decoding, plus the consistency check benchmark with loading and evaluation instructions. On Hugging Face, ReForm offers downloadable 8 billion and 32 billion weights, plus a quick transformers snippet showing tokenizer, model loading, prompting math to lean translation, and generate for verification. Alright, Figure 1 shows that the reflective approach delivers the best autoformalization accuracy across all 4 benchmarks. Autoformalization means turning natural language math into formal statements that a proof assistant can verify. The purple bars sit above the gray ones because the iterative critique loop improves semantic fidelity, which avoids subtle errors like quantifier slips. Gains are largest on the tougher sets, so the method scales with difficulty. The 32 billion model leads, while the 8 billion variant remains strong. So while Figure 1 showed the gains, Figure 2 shows how the method achieves them. The top panel contrasts one-pass generation with the loop that alternates autoformalization and semantic self-validation, so the model can critique and fix its own statement. The bottom panel illustrates prospective bounded returns, which means rewards accumulate backward but stay within limits. Auxiliary rewards shape critique quality, and a final task reward checks the end result. Okay, Table 2 shows which training pieces actually produce semantic fidelity. The full reflective setup reaches about 88 on Mini-F2F, signaling strong alignment between math text and formal code. Removing clipping, which means limiting reward totals to a safe range, degrades results most on the tougher sets. Auxiliary rewards that grade critique quality also matter because scores drop when they are removed. Reinforcement learning provides steady gains, while the one-pass paradigm trails badly with about 17 on AIME. So Table 1 summarizes the head-to-head results, showing that the reflective method consistently boosts semantic fidelity across all 4 math benchmarks. On average, semantic consistency rises by about 17%. The 32 billion model reaches roughly 98 syntactic correctness on Mini-F2F, which signals very stable formal code. The strongest baseline averages around 50 semantic, while the reflective model lands near 67, so the gap is substantial. Gains peak on AIME with roughly 30 points. Well, Table 3 shows that language model judges on consistency check are fairly reliable, with top accuracy around 86%. This classification generation gap means models find it easier to recognize faithful formalizations than to produce them, because recognition is a simple decision, while generation must synthesize consistent code. Gemini 2.5 Pro leads at about 86%. Open source QN 3235B reaches about 83%, which supports reproducible evaluation. These results justify using automated judges for the study. Wrapping up, 2 takeaways stand out. The reflective loop plus prospective bounded sequence optimization lifts semantic fidelity by about 17% across tough math sets, and the consistency check results suggest automated judges are reliable enough for research. The broader implication is clear. Critique-guided training can generalize to specification-faithful code and safer reasoning. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.